Let's take a look at the process of solving a linear equation. I want to solve the equation 2 minus 5x plus 9 equals 13x minus 2 times x minus 7. We're going to start by simplifying each side as much as possible. And to do this, we're going to multiply out the parentheses and then combine like terms. So the negative sign distributes across the parentheses here, across the addition. I end up with 2 minus 5x minus 9. And on the other side, the negative 2 distributes to the x and the negative 7, and we get negative 2x plus 14. Now on the left-hand side, we have like terms, constant terms, the 2 and the negative 9, so we can combine those to get negative 5x minus 7. And on the right-hand side, there are two x terms that we can combine to get 11x plus 14. So now both sides are simplified. To continue solving for x, I want to combine things from opposite sides of the equation. In particular, we're going to put the x terms together onto the same side and then move the constant terms together onto the other side. So we'll start by adding 5x. I want to do the opposite operations this time. I'm going to add 5x to both sides. So we get negative 7 equals 16x plus 14. And now we can subtract 14 from both sides, because the opposite of adding 14 is subtracting 14. So I get negative 21 equals 16x. And this means 16 times x, and the inverse property is division. So I'm going to divide both sides by 16 to get the final answer, x equals negative 21 over 16. And that's as simple as we can make it, because there's no number that divides both into 16 and 21. I should mention, it's always a useful idea to check your work, especially when solving equations. And we could check this by taking the value that we found, negative 21 over 16, and plugging it back into the original equation for all of the x's. And if we calculate out both sides, with x replaced with this number, we should get the same thing on both sides. I'm not going to take time in the video to do that, but you might want to check on a calculator and see that you do get, in fact, the same number. In this second example, we have a slightly more complicated situation because there are fractions and denominators, and it would be a much simpler equation if we didn't have those. So what I'd like to do first, before we try to combine terms and solve for x, I want to clear the denominators. And the best way to clear the denominators is to multiply each of the numerators by the least common denominator. In this case, looking at the denominators, we have a 4, a 6, and a 3, and so the least common denominator is going to be 12. So for the numerators that have more than one term, I need to put the two terms in parentheses, so I get 12 times x minus 1 over 4, 12 times 5 over 6, and 12 times 2 minus x over 3. And the reason why 12 is the best choice here is because 12 cancels with each of the denominators. I can cancel the 12 with the 4, and it leaves a 3 behind, because 12 divided by 4 is 3. I can cancel the 12 with the 6, and it leaves a 2 behind. And I can cancel the 12 with the 3, and it leaves a 4 behind. Notice that I can cancel these things because the 12 is multiplied by everything else up top, so it's a factor of the numerator, and therefore it can cancel with the denominator. So this gives us a simpler equation, 3 times x minus 1, 2 times 5, and 4 times 2 minus x. And now, just like with example 1, I can distribute the 3 across the parentheses. We can multiply out 2 times 5, and I can distribute the 4 across the parentheses and combine some like terms. So I end up with 3x minus 3 equals 18 minus 4x. And now, combining similar terms from opposite sides of the equation, I can add 3 to both sides to combine the constant terms. And we end up with 3x equals 21 minus 4x. And then I can add 4x to both sides to do the opposite of subtracting 4x. The minus 4x, the inverse of that, is adding 4x. And so we end up with 7x equals 21. So the final step is to divide both sides by 7. Since 7 is multiplied with x, the inverse operation is division. And we end up with our final answer of x equals 21 over 7. In this case, 21 is divisible by 7, so we get x equals 3. And so before we leave the problem, let's check. If we go back to the original equation and think about whether that answer makes sense, we're proposing that the solution is 3. So if x equals 3, does it make both sides of the equation equal to each other? Well, on the left-hand side, we end up with 2 over 4, which is the same as 1/2. And on the right-hand side, we end up with 5 over 6 plus negative 1 over 3. Negative 1 over 3 is the same as negative 2 over 6. And if I subtract the 2 from the 5, we end up with 3 over 6, which is the same as 1/2. So it works. X equal to 3 makes both sides of the equation equal to 1/2. I hope you enjoyed the video. Thanks for watching.